Okay, hello class. Okay, this is the second video. Alright. So this video we're gonna learn about interpreting and sketching graph. So interpret maksudnya soalan sudah bagi you graph and then you kena interpret and then you kena sketch a graph. Yang macam teacher cakap, let's say soalan bagi displacement time graph. Then dia minta kita tukar displacement time graph tu, kena tukar pergi bentuk contoh velocity time graph. So you kena pandai ubah. So this is the example. So ada satu perkataan sketching. Sketching mean kita kena lakar. Lakar sendirilah. Lakar means tidak perlu guna pembaris biasanya. Okay. Melainkan dia memang straight line, so you boleh guna pembaris. Tapi kalau you mark, dia macam ada curve, so you kena guna freehand lah. You tidak boleh guna pembaris. Itu maksud sketch. Okay. So we continue. Interpreting displacement time graph can help to sketch velocity time graph and vice versa. Okay, macam teacher cakap tadi. So velocity time graph can also be interpreted into acceleration time graph and vice versa. The skill in interpreting and sketching graph is important to solve linear motion problem. Study the examples given. Alright. Example 1. Figure 2.24 shows the displacement time graph of an object in linear motion. Excuse me. So this one, dia bagi displacement time graph. Displacement against time. So dia punya gradient, this gradient is referred to velocity. Alright, the question A, determine the velocity of the object at each stage of its motion. So means kita kena kira satu-satu lah. Stage 0 to 6, 6 to 12, 12 to 20. Alright, kita tengok dia punya solution. So velocity is equal to gradient of displacement time graph. Okay, you already know. So 0 second to 6 second, the velocity is alright, wait. Okay, from 0 to 6 second. So kita kena calculate the gradient. This gradient. Okay, to calculate, macam biasa, you kena guna y2 minus y1 over x2 minus x1. So, 6 minus 0 over 6 minus 0. So, you will get the velocity for this section is 1 meter per second. So, easy. Then you measure and you calculate the gradient from 6 second to 12. Tengok dia punya shape. Okay, means you kena kira this one. So you measure, you dapat the velocity is 0. Means the object is at rest. Okay, dia tidak moving. And then 12 second to 20. 12 to 20. So this is the gradient. So ini kita boleh calculate. 10 minus 6, 12 minus 12. So you will get 0.5 meter per second. So teacher tidak payah tunjuk detail lah, okay? You kena pandai cari tu y2 minus y1, x2 minus x1. You kena refer balik lah video yang the previous video, okay? Alright. Question B. Interpret the displacement time graph in figure 2.24 to sketch a velocity time graph. Okay, first you interpret kan. Kita sudah interpret sini actually. Okay, kita sudah cari dia punya velocity. And then sekarang you kena sketch velocity time graph. This one, the y-axis is velocity. So you kena tulis V, the unit is meter per second. Make sure jangan lupa dia punya unit. And the x-axis is time, ataupun you boleh tulis t and second kan dia punya unit. So you plot macam ni. y against x. So this one, the scale actually di sini kurang 1 bar sini ya. 0.1, 0.2, 0.3. So kurang 1 bar. So nanti kalau you sketch the graph, dia punya scale mesti cantik. Okay. So tengok 0 to 6 second, dia punya gradient tadi ialah the velocity is 1 meter per second. So you kena buatlah from 0 at 1 second, 1 meter per second, this one. Ini dia punya velocity. This one, 0 to 6. Jangan salah, okay? Jangan lebih, jangan kurang. Garis cantik-cantik lah. Kalau ini straight line, you boleh guna pembaris. Alright, from 6 to 12, the velocity is 0. Means di bawah sini. Means 6 to 12. Okay. 6 to 12. Buat cantik-cantik lah ya. And then 12 to 20. Di sini dia 0.5. So ikut mark dia. Velocity dia 0.5. So dia di sini. So you sudah berjaya convert from the displacement time graph to the velocity time graph. Actually dia easy. Tapi kalau you tidak pandai cari velocity dia, you tidak pandai interpret, so dia ada problem. And then kalau the y-axis dia you sudah plot salah, ini salah lah. Means you belum mahir untuk interpret. This one is sangat important. Alright? Okay. Second example, coba camera, okay? Wait. Alright, example 2. Figure 2.26 shows the velocity time graph that is plotted based on the linear motion of car driven by Encik Kasim. He drives his car at a speed 30 meter per second and applies the brakes when he sees an obstruction on the road. Interpret the velocity time graph of the motion of his car and sketch displacement time graph and acceleration time graph. So this question give you velocity time graph. Kan? So dia minta you convert to displacement time graph and acceleration time graph. Alright, as usual you kena pandai interpret this graph. So kalau velocity, the gradients shows the acceleration, stand for acceleration dia. Alright, so kita tengok. So solution, actually ini dia sama saja, cuma dia kasih color. So, kita kena cari dulu dia punya, kita kena interpret dulu. So the displacement, macam mana mau cari displacement kalau velocity time graph? Means you kena cari dia punya area under graph. This one. From 0 to 6 second, the displacement is area A. So this is a square times length times width. So the length is 6, the width is 30. So 30 times 6 you will get 180 meter. Ini displacement. Kenapa cari displacement? Because nanti kita kena buat displacement time graph. And then why we interpret the acceleration? Because nanti kita kena sketch acceleration time graph. So find the acceleration. Acceleration is equal to gradient of the graph. So for this section, section A, the gradient is 0 kan? Okay, 0 meter per second square. Alright, from 6 to 10 second, find the displacement. So this one is triangle. That's why lah 1 over 2 times 30. 30 is the height. This one, the height, and 4 is the base. This one yang kadang-kadang student selalu salah because they think, oh di sini 10, then they put 10 here. Okay, actually boleh letak 10. You kena tengok from 6 to 10 dia ada 4 saja. Alright, so you multiply all this number, you will get 60 meter for displacement. And then the acceleration is, so here is ada gradient kan, right? Ada gradient sini from point here, kita letak point 1 to point 2. So you kena measure dia punya acceleration, 0 minus 30 over 10 minus 6. So you will get negative 7.5. That means they decelerate. Alright, use the interpret. So now time to answer the question. First, sketch displacement time graph. Okay, you already interpret. Now kita sketch dia punya graph. Displacement time graph. Alright. So macam biasa, you kena buat y-axis. This one, y-axis stand for displacement. The unit is meter. And the x-axis stand for time. And the unit is second. Dia punya scale you kena pandai buat. Okay. So the displacement. Okay. Now, tengok. Macam mana mau tahu the highest number for the y-axis, teacher? So you kena tengoklah, you kena tambah dia punya total displacement. 180 here plus 60. So when you total up, dia akan jadi 240 kan? 240. So that's why the maximum number here is 240. And ada berapa section sini? Ada 2 section. So nanti kalau you plotting, means ada 2 point. Okay, the first one displacement for 0 second to 6 second. Nanti you akan plot sini 180 di sini. Okay, and the time is 6 second. Okay, nanti you mark X. And then the second displacement is 60 meter after 180. So nanti you akan mark di sini dekat 240. Because selepas 180 you kena tambah 60. The next displacement dekat sini. Okay. So the time taken is 10 second. Di sini. So masa you plotting, you sketch this graph, you kena guna freehand. You jangan pandai-pandai guna pembaris. Okay. Nanti, let's say you guna pembaris kan. Let's say lah you guna pembaris. Nanti you garis macam ni. Then you garis macam ni. So means itu bukan sudah sketch. You sudah menggunakan bantuan ruler. Sketch, it means freehand. Okay. So you sudah dapat displacement time graph. Now we go to acceleration time graph. Macam biasa, kena ada y-axis and x-axis. So the y-axis is acceleration. The unit is meter per second square. And the x-axis is time. The unit is second. Kena refer balik the data that you interpret here. Kan? The first one, 0 to 6 second, the acceleration is 0. So di sini, that's why dia punya answer di sini 0 until 6 second. And from 6 second to the 10 second, the acceleration is negative 7.5 meter per second square. So y-axis lebih kepada bawah. Kita tidak payah pakai di atas kan, because the value is negative. That's why from 6, yeah, you mark lah dekat 7.5 sini. Kan tu, dia sudah mark sana 7.5. So you buat sampai 10 second saja. Okay, then finish. So easy lah. Alright, no problem with this one. Teacher harap kamu tidak masalah. Okay, so kita continue. Alright, kita baca dulu smart info. To determine displacement, the area under graph needs to be calculated. Okay, ini yang kita sudah belajar sebelum ini. Alright, the next example is solving problem involving linear motion graph. So ini kita kena solve problem. Alright. Okay. First example as the velocity time graph in figure 2.3 shows the motion of Hasri. Determine his first one is acceleration. Alright. So acceleration. So di sini graph ini ada 3 section kan? Section A, section B, section C. Means each section you kena calculate dia punya acceleration. Like this solution. Okay. So acceleration, how to find the acceleration? You kena check dia punya gradient. So from 0 to 3 second, that is section A. So you measure lah dia punya gradient. So you akan dapat 2 meter per second square. 6 minus 0 and 3 minus 0. Okay. So then from 3 second to 6 second, the gradient is here. So 0 kan? Alright. And 6 second to 10 second, calculate lah dia punya gradient. Alright, you akan dapat negative 1.5 meter per second square. Kalau you dapat positif, means salah lah itu. Okay, because you tengok dia punya shape pun ke bawah kan? Means dia punya value mesti negatif. Alright, next, how to find the displacement? Displacement, remember, you kena calculate area under graph. Because ini velocity against time. Area under graph stand for dia punya displacement. Alright. Okay, find the displacement area under graph. That means di sinilah you kena kira area under graph. Okay. Ataupun kalau you confuse, you kira section by section. Section A, section B, section C pula C. Alright. Ataupun dia boleh jadi 2 section saja. Wait. This one is trapezium. And this one is triangle. So ini section A, ini section B. So ikut mana yang you selesa. Actually this one pun kita boleh assume as one trapezium. Okay, this one is the height. So the formula for the trapezium is 1/2 plus A plus times A plus B. So here A, here is B. So the length for A is 3, 1, 2, 3. So 3. Kan? So B is 10. That's why 3 plus 10 here. Times the height. Here is the height. So the height is 6. So when you measure, you akan dapat 39 meter. Alright? Itulah dia punya displacement. And average velocity. So you sudah dapat displacement. So senang untuk cari velocity. Tinggal substitute bagi formula. Average velocity is equal to displacement over time. So dia punya displacement is 39, time taken here is 10 second. That's why 39 over 10 you will get 3.9 meter per second. Unit, don't forget, okay? Don't forget the unit. Okay. Dan example 2. Figure 2.31 shows the velocity time graph of the linear motion of a car. Interpret the velocity time graph and sketch a graph of. Okay, sama juga soalan sama. The first step you kena interpret, then you kena sketch a graph. from velocity time graph to displacement time graph and acceleration against time. Look at the solution. Okay, first you kena analyze, interpret dulu this graph. Ada 3 section here, right? There is 3 section, 0 to 10, 10 to 30, 30 to 50. So find the displacement and find the acceleration. So displacement easy, aku nak cari dulu dia punya area under graph. Okay, so you will get 100 meter because square, rectangle kan, panjang darab lebar saja. So for area B, this is a trapezium. So use the formula of trapezium, then you will get 260 meter. Alright, and the section C is triangle. So you boleh guna formula triangle 1/2 times dia punya base time dia punya height. So you will get 160 meter. Alright, and then how to find the acceleration? So acceleration, this is velocity time graph. Time graph means the gradient shows the acceleration. So from 0 second to 10 second, the gradient is 0. Kan? Tu tengok straight. Alright, then section B, you boleh calculate because ada gradient. So gunalah 16 minus 10, 30 minus 10. So you will get the acceleration is 0.3 meter per second. Positive acceleration because naik ke kanan. This one confirm negative. So 0 minus 16, 50 minus 30. So you will get negative 0.8 meter per second square. So ini actually you sudah mahir. Jangan salah tengok marking point itu berapa. Jangan salah kira dia punya scale. Okay. So then kamu boleh sudah cari total displacement dia. Alright, total displacement dia. Kalau soalan mungkin tanya what is the displacement after 30 second? Okay, after 30 second. So you kena kira this one sajalah, 100 plus 260. Selepas 30 saat berapa displacement? So di sini saja. Okay. Mungkin juga soalan tanya what is the displacement after 50 second? Means you kena kira semua. Okay. Alright. First, sketch displacement time graph from the velocity time graph. Okay, kita ada 3 point kan tadi, 3 section. Alright, displacement kalau 0 to 10 second, kita padam dulu. Kita tengok this one. From 0 to 10 second, the displacement is 100 meter. 0 to 10 second. Sampai sini displacement dia ialah 100. So you mark X. Okay, from 10 to 30 means 30 lah. 30 dia punya tu displacement to 60. 30 to 60 plus yang sebelum ni, so 360 lah. Jangan you mark betul-betul itu 60, okay? So you kena tambah dengan yang the previous displacement. Okay, that's why di sini kita kena mark dia dekat 360. Because this graph kan dia bersambung kan. So from the 100 displacement you kena tambah lagi 260. That's why dia jadi 360 kan. That's why kita kena mark sini 360. And then 30 second to 50 second 160. So from 360 tadi you kena plus 160, kita akan dapat 520. Alright. So mark dekat 520. Okay, then apa mau buat ni teacher? So you sketch lah graph itu kan, freehand. Okay, buat cantik-cantik lah. Okay, dia tidak akan jadi straight line itu kalau kita sketch. Alright. Coba kita cantik-cantik dulu. Lebih kurang begitulah. Okay, and then sketch from displacement velocity time graph to acceleration time graph. So sekarang kita tengok yang acceleration punya. So from 0 to 10 second, 0 to 10 second, the acceleration dia 0. That's why di sini. And then from 10 to 30 second, the acceleration is 0.3. So 0.3 is here. Okay. 30 to 50 second, negative 0.8. So di bawah. Alright. Ini saja. So ini famous lah keluar dalam ujian-ujian. Okay. So kalau masih confused, saya rasa ini pun mungkin ada banyak soalan yang mungkin yang kamu akan tanya. Sebab kalau you mistake sikit, you salah interpret, means you akan salah semua. You akan problem. Alright. First kena faham dulu shape, displacement time graph, velocity time graph, and acceleration time graph. Kena faham tu shape maksud dia macam mana. Okay. And then jangan lupa the way to calculate gradient. Okay. Kalau velocity time graph, how to interpret displacement time graph and acceleration time graph. So semua shape graph itu, shape of the gradient, dia akan bagi maksud yang berbeza. So you can differentiate all of that. Alright. So that's all for today. Video is quite long. So you tengok perlahan-lahan. Tidak faham, ulang balik. Kalau tidak faham juga PM teacher. Alright. Teacher akan tinggalkan exercise. Teacher akan bagi gambar nanti exercise itu. Okay, that's all for today. Enjoy your day. Enjoy physics. Okay, bye-bye.